Dahlin again, and what we're going to do today is we're going to figure out how to calculate using trigonometry the speed and the angle of a projectile if you don't know it at the beginning. The two pieces of information you do need to know is how fast is it moving sideways and how fast is it moving upwards. If you look at this picture right here, right, that is showing me how fast it's moving sideways. Sideways, we would call that our Vx. And this arrow here is how fast it's moving upwards, which we're going to call the Vy. Now, what you got to keep in mind is if you have a projectile that's moving sideways and upwards at the same time, you're actually moving at an angle, right? And just keep in mind, I mean, remember, we've launched these things, we've watched videos of them, and they all have this kind of same shape. Depending on the angle, they look slightly different, but they all have, this kind of curved or parabolic is what it's called, parabolic shape. Well, physicists were able to measure things. So you could have somebody standing from one direction and measure how quickly is this thing moving sideways across the ground and how quickly is it moving upwards. And then they realized they could use that to create a triangle. So imagine here a triangle where instead of an arrow being 10 meters per second, the side of the triangle was 10, right? And then the up arrow represents a line that starts at the end of that arrow from the Vx and goes up. Right? This would be our Vy, and that's going to be, we're going to call that 5. Well, if you then connected those two, you see how we have our right triangle? Where this is a 90-degree angle, and this is your hypotenuse. Okay, and so basically what they're saying is, okay, we know, let's say this is our projectile. We know that it's moving and it's going to have this angle here, and then this arrow is going to represent, or the hypotenuse of our triangle is actually going to represent the speed of the projectile. So how fast it's actually coming out of our marble launchers, as an example. So how do we figure this out? Well, somebody a long time ago by the name of Pythagorean came up with this. You have a triangle with a right angle in it. If you take a squared plus b squared equals c squared, meaning one side called a squared and the length of the other side called b squared. If you add those together, those equal the third side, which has to be the hypotenuse, or the longest side of the triangle. So we could call this one A and this one B, or we could flip them. It actually really doesn't matter. But what we do know is that if you take 5 squared, if I flipped it and made this one A, and then change it to make this one B, and if I add that to 10 squared, that's going to equal C squared. Okay, now again, order of operations here, really important. You always have to do PEMDAS, and in PEMDAS, your exponents always come before your adding. So PEMDAS, 5 squared is 25, plus 10 squared is 100, equals C squared. Now we can add those together. We get 125 equals C squared. And then to get the C, right now, what this is actually saying is 125 equals C times C. So we're asking ourselves the difficult question, what number multiplied by itself would give us 125? Well, to get rid of that, the opposite is to take the square root. Okay, if you take the square root, then this cancels out. You get C equals the square root of 125, which if I take the square root and do 125 on the calculator, I get 11.18. Now, look real carefully at the question. This is the length of that. But what unit should it have? Go back to the original starting numbers. The units here are actually meters per second. So this is telling us how fast the marble was launched out of the launcher. Okay, so that's finding us the speed. The second piece that we have to find here is what is the angle? Because when you launch a marble, remember, we've looked at this, angle makes a huge difference. The angle is going to determine how far and how high up in the air that marble is going to go. So it's not only important how fast the marble is going, but it's also important at what the angle is. And so to do that, now we just use SOHCAHTOA. Okay, so SOHCAHTOA basically says if you're trying to find this angle here, I'm going to call this theta. That's the symbol we usually use. You can use the sides of the triangle to help us figure out what that angle should be. Now that we know all three. Now, I'm going to recommend something here. Let's use TOA. What does TOA stand for? TOA stands for tangent of our angle equals the opposite side divided by the adjacent side. Let's think about why we might want to do that here. The reason for that is because what if I screwed up here? What if I mistyped something? I got a lot of steps here. What if I mistyped something and this actually 11.18 isn't the right number? That is what we would be using for the h, the hypotenuse, and so, and for ka, sine and cosine. But the 5 and the 10 were given to you. You know those are good numbers. The problem that we're going to then have to come across is which of these is going to be considered the opposite and which of these is going to be considered the adjacent. So, looking at our triangle here, right? Here is our angle. The side that is opposite to the angle is our opposite. So this, I'm going to erase some things here to neaten things up. Right? This then is our opposite. And then the side that's touching that angle, but not the hypotenuse, must be the adjacent. Okay, so to solve, we're going to use tangent. Tangent of our angle equals opposite over adjacent, or 5 over 10. Okay, now in this one, it's the angle that's the unknown. So on your calculator, if you look at your calculator, look at sine, look at cosine, look at tangent. I'm guessing on most of your calculators, you have text written right above it that says sine -1, cosine -1, or tangent -1. What that is doing is that is the function or the math you need to do if you're trying to solve for the angle. So to solve for the angle, what we do is this. Your angle, well, actually, I'm going to take a step back. This is just like algebra. You're doing the opposite to cancel things out. We're actually trying to cancel out the tan. So what we're doing is we're actually taking tangent of -1 to both sides. Okay? If you take tangent of -1 of tangent, those cancel out. You'll just get your angle. So the angle is equal to tangent of -1. And then here we got to do it as a fraction. Most calculators give you a parentheses. Okay? Some calculators don't. You might want to just take 5 divided by 10. It'll give you your number. In this case, 0.5. And then take tangent -1 of 0.5. Okay? So I'm going to do that. It's usually the secondary function. And when you do that, you find that your angle is 26 point, I'm just going to round it 2 decimal places, 57 degrees. Okay, so there's my two answers. I have, and we'll go right actually. I'm launching my projectile at 11.18 meters per second at an angle of 26.57 degrees. There you go.